All right, so welcome back to another video. In this episode, we are going to talk about ordinary differential equations. All right, now, what do we mean by ordinary differential equations? Ordinary differential equations by giving an equation and then you finding the value of y if possible. Right, now we have four types, but here we are going to talk about the separable method. The separable method. Now, the separable method, it has its form, the standard form. Before you can separate a variable, it has to be in a standard form, right? And the standard form is given by dy dx equals p of x times q of y, right? Here, what do you mean by separation? You see, you have p of x and you have q of y. So here, make sure that the y terms move to one side. That means you are isolating the y term and you're isolating the x term. So here, we multiply by dx, multiply by dx. So this takes off this, and we have dy equals p of x, q of y dx, right? Here, we still have q of y in the midst of x, right? So what we do is that we divide here by q of y and here too by q of y. So this goes off. So we have 1 on q of y dy, and that should be equal to p of x dx, right? So here we have been able to separate the variables perfectly, right? So here now you can go ahead and integrate. So integrate both sides of this, then you make y the subject if possible, right? So let's look at a problem under the separable method, right? So we have y prime is equal to 2y squared minus 7y plus 3, right? So this is what we have, and we want to solve this ordinary differential equation. So how do we know that this is a first order? We can see that this has been differentiated only once. So y prime symbolizes that this is a first order differential equation. And then before we can solve this, means that the dy dx must go and represent the y prime. So now we have 5 dy dx equals 2y squared minus 7y plus 3, right? Here we have dy dx here, and we have 2y squared minus 7y plus 3. So what we have to do is make sure that we send this dx to this side and bring this to this side so that we separate the variables, right? So we have the x here, the x here. So this cancels this, and we have 5 dy equals 2y squared minus 7y plus 3 dx. So we divide, of course, this part by 2y squared minus 7y plus 3. Same to this part as well, so that this takes off this, and we have 5 on 2y squared minus 7y plus 3 dy equals dx, right? So here we have now been able to isolate the variables into x components and the y components. So now we can go ahead and integrate both sides with respect to their variables. So here, integrate here and then integrate this part as well. So We go up here, 5 on 2y squared minus 7y plus 3 dy is equal to the differential of the integral of the x is of course s plus c, right? So let's move up. 2y squared minus 7y plus 3 dy is equal to s plus c. So here, before we can integrate this, we have to apply what we call the partial fractions. We have to integrate this using the integration by partial fractions. So applying the partial fractions on this function, 5 on 2y squared minus 7y plus 3, we know that we can factorize the denominator here, so we can have 5 on 2y minus 1 and then y minus 3, right? So we all know that this is this, right? So now this, we can rewrite it in the partial fraction form, express that in the partial fraction form. So we have this is equivalent to a on the first term plus b on the second term, right? So once we have this, we have to find a common denominator, right? And then is this and this, right? So what we do here is the common term is going to be this and this. So this and this means that this goes off from this part and we have only this, plus b into 2y minus 1 all over 2y minus 1 y minus 3, right? So now what we do is that, of course, we have here, right? So we can see clearly that our denominators are the same. So since the denominators are the same, let's equate the numerators. So we equate the numerators, which is 5 equals a into y minus 3 plus b into 2y minus 1, right? Once we have this equation, what we can do is use the y, right? So if y minus 3 equals 0, then y will be equal to 3, right? So we substitute this into the equation and find one of the variables. So we have 5 equals a into 3 minus 3 plus b into 2 into 3 minus 1. So we can see clearly that the a will go off because 3 minus 3 is 0. 0 times a is 0. So we have 5 equals 0 plus b into 2 times 3 is 6 minus 1, and that is 5, right? So we can say that our b, 5 will be equal to 5b. So we can say that our b will be equal to positive 1, right? So we have our b to be positive 1. Now, let's come up here and use so now let 2y minus 1 equals 0. So we can say that 2y is equal to 1, and this will imply that y is equal to half. So substituting y equals half into this general equation, then we're going to have 5 equals a into half minus 3 plus b into 2 into half minus 1, right? So we can say that 5 is equal to a into negative 5 on 2 plus b into 0, you see, right? So here we can see that we have 5 equals negative 5 on 2a plus 0, right? So we have 10 equals negative 5a. So we can say that our a is 10 on negative 2, negative 5, and that is equal to negative 2, right? So now we have the value for a and we have the value for b. Once we have identified those values, we substitute them into this, right? So in doing that, we're going to have 5 on 2y minus 1 into y minus 3 is equivalent to our a here is negative 2. So, of course, negative 2 on 2y minus 1 plus our b is positive 1 on y minus 3, right? So now we have been able to decompose this function, right? We have been able to decompose this function and obtain the values of a and b. So now let's go ahead and substitute this result, this simplified result, into this, right? So now we are substituting this simplified results into this. So we have integral of this negative 2 on 2y minus 1 plus positive 1 on y minus 3, right? Or dy equals x plus c. So now we can see that we can easily integrate this function in the bracket, right? So we can decide to separate them or integrate straightforward. But to make work so easy, let's separate the functions plus integral of 1 on y minus 3 dy, and that is equal to s plus c. So we can go ahead and integrate this, integrate that. After that, we combine all. So integrating negative 2 on 2y minus 1 dy, right? We can factorize the negative 2 out. So we have 1 on 2y minus 1 dy, right? So here we are going to have negative 2 integral of. So what I will always advise is when you get here and you don't know what to do, just use substitution, use up, right? So let u equals 2y minus 1, right? So if that is true, then differentiating both sides with respect to their variables, then you say that du will be equal to differential of 2y is 2 dy, and then differential of 0 is of course 0 because it's a constant. Differential of negative 1 is of course 0 because it's a constant. So now we are interested in dy. So let's divide by 2, here 2 by 2. So we have dy equals du on 2. So once we have dy to be du on 2 and u to be 2y minus 1, let's do that substitution here. So we have So we have -2 integral of 1 on 2y minus 1 is now u. So we have u du. Now dy is now du on 2, right? So by factorizing the half here, we have -2 times half the integral of 1 on u du, right? So this would automatically take so this, and then we have negative into 1 on u du. So integrating this, we are going to have negative. You know that the integral of 1 on u is ln absolute u, right? The reason why we are using the absolute is that to avoid any negative number. You know that ln doesn't take any number less than 0. So once we have obtained this, let's go ahead and do same for this. So, all right, so here, once we are done with this, we can say that, but u was equal to 2y minus 1, right? So we do that substitution, and then we have negative ln of 2y minus 1, right? Absolute of that. So now we have the value of this to be this, right? So let's go ahead and move to the second term, which is integral of 1 on y minus 3 dy. So likewise here, we can apply the same u sub and integrate this. So let's, for instance, k equals y minus 3, right? So differentiating both sides, we have the k equals dy. So let's do the substitution here. This is now k, right? And then dy is the k. Integrating 1 on k is ln k. So we have ln absolute k. But we said that k should be equal to y minus 3. So we have this equals ln into y minus 3. Right? So let's go up here and put them into a combined form, right? So we have negative ln into 2y minus 1 plus ln into y minus 3. And that should be equal to s plus c, right? So once we have this, we have to do proper arithmetic, right? Put addition first before subtraction, right? You know, of course, board maths. So ln into y minus 3 minus ln into 2y minus 1, right? So this should be equal to s plus c. And this right here, we know that in your pre-calculus, you know that when you're having logarithm, right, log of a minus log of b, we can always have log a on b, right? This is a property. So we apply this knowledge in here, right? So this, we are going to have ln into y minus 3 on 2y minus 1, right? And this should be equal to s plus c. So once we have this, we all know that ln has a natural base of e, right? So Once we have this, we can introduce the e, right? So introducing the e, we are going to have so introducing the e, you're going to have e power ln into y minus 3 on 2y minus 1, right? And this should be equal to whatever you do to Kojo, you do same to Einstein, right? So we have e power x plus c, right? So here, what we do here is that you know that when you have an exponential function, you can drop the exponent, right? So this big thing we have here will drop down, right? So we have y minus 3 on 2y minus 1. Of course, they are all in the absolute sign, just to avoid the negatives in there. So we can have ln e here. So this will be equal to e power x plus c, right? So now this is, we know that ln e is equal to 1. So once we know that this is 1, then the whole of this here, this will go off because 1 multiplied by everything is the same thing. So we have 1 minus y minus 3 on 2y minus 1. So the absolute is, of course, the idea that we are interested in the positive numbers. So we can now go away with the absolute sign. So here, this should be equal to e power x plus c. But of course, we know that, but when you have e power x plus c is the same as e power x times e power c, right? So here, we can say that we have y minus 3 on 2y minus 1. And that is equal to e power x times e power c, right? But also, we can say that e power c should be equal to a because it's a constant, right? So once we have that, once we have this, we can say that y minus 3 on 2y minus 1 should be equal to e power x times the a, right? So position this well, we have a e power x, right? So now we are interested in the value of what y, but sometimes we are not able to make y the subject. But in this case, we can see that we can be able to make y the subject by multiplying through the denominator, and then we can factorize y out. So when we do that, we have y minus 3 should be equal to a e power x times 2y minus 1, right? So once we have this, then we have y minus 3 is equal to, spread this to all of the items in the bracket. So we have 2ay e power x minus a e power x, right? So the rest is algebra. So we are interested in y. We have y here, we have y here. So what do we do? Let's send this here and bring this here to avoid negatives. So we can have, this is negative here, crosses here, becomes positive a e power x. Maintain the negative 3. That should be equal to 2ay e power x. Then we are sending the y to this side, minus y, right? So once we are done with this, because we are interested in y, we make y the subject. We make y the subject from here. So y out, 2y, we have 2a e power x minus 1, right? So we need y, so we divide by the combined function. So 2a e power x minus 1 here, 2a e power x minus 1 here, right? So this takes off this, and then we can finally have y equals a e power x minus 3 on 2a e power x minus 1. Right, so let me write the general solution clearly up here for you. So we can have finally y equals a e power x minus 3 on 2a e power x minus 1. So this becomes our general solution. This is the general solution, right? So this is our general solution. So once we have the general solution, the next is we have been given an initial, right? Where we have y of 0 is equal to 1, right? So once we have this information, it means that our y is equal to 1 and our x is equal to 0. So once you have this, put them inside this, then you find a constant, right, which is the a. So let's do that. Right, so once we do that substitution, our y is 1 and our a is what we are looking for, and our x is 0, right? Minus 3 on 2a e power 0 minus 1. Right, so here we are interested in a, so let's keep factorizing. Also, we can simplify this and we have a into, e to the power 0 is always 1. So we have 1 here minus 3 on 2a into 1 minus 1. Right, so once we have this, we can still simplify it and we have a minus 3 on 2a minus 1. Right, so we are interested in a, so let's cross multiply. So we have 1 into 2a minus 1 is equal to a minus 3. Right, so we are interested in a, so do further simplification. Right, so bring this here, send this down. So we have 2a minus a should be equal to minus 3 plus 1. So we have a is equal to minus 2. Right, so now we have our constant, right? So once we have our constant, we substitute into the general solution, and then we have our final simplified solution, right? So now we have y is equal to, our a now is negative 2. So we have negative 2 e power x minus 3 on 2 times a, which is negative 2 e power x minus 1. So when we simplify this, you have negative 2 e power x minus 3 on negative 4 e power x minus 1. Of course, I'm so happy, and I know you are also happy as well. Ladies and gentlemen, that is the end of this content. I really appreciate your time, but don't forget to subscribe. Watch out for the next part. And then those who are not more technique in the integration aspect have all the techniques in the integration, and that will aid you in the differential equations. If you don't know integration, ODE will be very difficult for you. So watch it out there. Bye-bye.